Hello young discoverers, I have a riddle for you. Heat from the sun makes me rise. When I freeze, I turn into ice. You may drink me for free or I come with a prize. Who am I? Yes, you all have guessed it right. The answer is water. Children, when water freezes, it becomes ice, solid. When ice melts, it's liquid, and on heating, it's steam. So, different states, different names. Is this physical or chemical change? You all have learnt about physical and chemical changes in your upper primary classes. Let's see how much you can recall. Physical and chemical changes, they occur all around you every day. Let me give you a small task here. Create your own chemical and physical change story. For example, it's your birthday, your brother is decorating the place with cutting colorful strips, blowing balloons, mother is baking cake for you, father is cooking your favorite food, and so on. Make sure that your story includes at least 5 different chemical and physical changes. Now, look here, I have piece of old newspaper. 3 pieces I have got, 1, 2 and 3. Now, 1 I will keep for reference. This is the second piece and this is the third piece. Now, all these pieces you just observe carefully. They almost are of same size here. Now, this, as I told you, is for reference. This one I am just going to fold it and make something out of it. So, okay, let me quickly just do it. And sort of I have created a fan type of a thing. And can you compare the size of this piece of newspaper with this original one? So, this kind of change where there is a change in size or appearance, what will you term it as? A physical change. Yes, I am sure you can recall from your 7th and 6th classes, you have already done this. And well, why don't you compare and measure the area of these 2 papers? You can become a mathematician along with the scientist. Okay, now this paper, I have the third paper. Let me burn it. And if you want to burn it, children, you should do it under the assistance of your parents if you are doing it at home. So, children, can you see that where the original piece of paper is going? See, what is the end product? Let us compare it with this original piece of paper. Is it same? What is the difference can you see here? Some new substance has formed and this is the ash which you can even see rising. So, here again there is a moral lesson for you. We should never burn paper or garbage in open because so much of pollution and ash is made. We should always dispose it and bury it under sand so that compost is made. Yes, coming back to our science, see, some new substance has been made. So, here a chemical change has occurred. So, can you recall and define what is a chemical change? A chemical change is one in which one or more different substances, they interact with each other to produce one or more different substances. They are called chemical changes. And always remember, in this change, new substance is formed. So, today we are going to learn about chemical reactions and equations of class 10th. Many such changes are happening around us. Children, have you seen that sometimes the copper vessel with some kind of a greenish coat on it, and yes, see, I have an iron substance. Can you see some kind of a brown substance on it? Yes, these are the chemical reactions which are happening all around us. And I also have got these cut potatoes and brinjal. Can you observe some kind of brown layer on it? And yes, children, sometimes when your mother gives you apple to eat in school and you open your tiffin, what do you find? The apples are no more freshly cut. Look, they have some kind of brown layer on it. So, all these changes are happening around you, and these are chemical changes which we are going to study in detail. So, my little discoverers, you have seen the changes on the surface of these vegetables and some substances around you. The little explorer or the discoverer in you, I am sure, must be wondering why these changes are happening. Put on your thinking caps and go explore and find out the answers. The curiosity is the mother of invention. And yes, I am sure you will be able to define what a chemical change is. Let's try writing it down. Chemical change is also called a chemical reaction. You may perhaps be wondering as to what actually is meant by a chemical reaction. How will you come to know a chemical reaction has taken place? Let us perform some activities to find out answers to these questions. So, here is the first activity where I will bring a magnesium ribbon. I am sure you must have seen the magnesium ribbon, but yes, before we start burning it, we need to rub it nicely with sandpaper. So, here I have the strip of magnesium ribbon, and after rubbing it, we will burn it. See the dazzling flame, but yes, never stare at it. This flame is very sharp and can harm your eyes. Be careful to maintain proper distance, and it would be better if you wear eye protection. And yes, always perform this activity under supervision of teacher. What are you observing? Along with dazzling flame, you can see white powder falling into this watch glass. What is this white powder? This is the new substance, this white ash. I would like to ask you one question here. Is this white ash heavier or lighter than the original strip of magnesium? Now, let us compare this white ash with the original magnesium ribbon. This is continuous strip of hard lustrous metal, and here you can see that this is white powdery substance. Though the state has not changed, but yes, there is definitely some difference in the appearance. You can observe the change carefully, and children, this is very important skill you need to develop. As a discoverer, as a scientist, your observational skill has to be very, very sharp. Magnesium ribbon has changed into white powder. You can see the change in color. This was hard, lustrous, shiny metal, and now it has turned into white powder. What is the other observation you can make? Well, this is a hard, lustrous metal, and here you can see this is a powdery substance. Though the state has not changed, but definitely somewhat the appearance has changed. Now it is soft powdery ash. Is this a chemical or a physical change? Correct. This is a chemical change, and this is, you can say, a chemical reaction has occurred here. Can you name this white powder? Yes, magnesium has reacted with oxygen present in the air. So, magnesium and oxygen has reacted. I am sure you are getting the answer right. It is magnesium oxide formed due to reaction between magnesium and oxygen. So, can you guess now why magnesium ribbon should be cleaned before burning in air? Now, let us perform another interesting activity. I have made aqueous solution here of lead nitrate and potassium iodide. What is aqueous solution, children? Yes, when solute is dissolved in water as solvent, it becomes aqueous solution. So, here I have made these two aqueous solutions. Now, let us see what happens if we mix these two solutions. So, here is the petri dish and observe carefully. Wow! I am sure you all are very excited to see the change in color. Such bright yellow cadmium, and this is again an indication that yes, chemical reaction has taken place. Children, now you see what science is all about, and you must be wondering, oh, is this not the way the people are making various colors? I am sure this is another indication will help you to determine that chemical reaction has occurred. Here I have a very small assessment for you. I have water in this beaker and I am going to add a very small amount of a substance. See carefully. Now, is this also a chemical reaction happening? So, this is what is quiz for you. You have to tell me whether this is a chemical change or not. Ponder over, think and deduce your answer, because this is what scientists also do. When they have to discover something, they seek answers to the various questions which come to their mind, and I am sure you are the next scientist in the making. Now, there is another interesting activity for you, and you must record it so that proper understanding is developed after you see the observations, because in science, children, observational skills have to be developed, and they get developed when you are watching experiment carefully or doing it yourself. So, here I have made dilute hydrochloric acid in this boiling test tube, and here I have brought zinc granules in watch glass. Now, first observe the surface of the zinc granules. Note down the color. Aren't they shining? I am going to put one zinc granule into the dilute HCl in the boiling tube, and you have to note it very carefully. What are the changes going to happen? See children, can you see some changes happening on the surface of the zinc granule? And observe the bubbles arising from under the zinc granule. These bubbles in science are called effervescence. So, have you noted down that evolution of gas is happening here? Yes. Now, which gas is being evolved? Can you guess? We will learn in detail about this later in the chapter. Let us touch the test tube. Is there any change in temperature? Oh, it is little hot now. That means there is change in temperature. So, another observation which helps us to determine whether a chemical reaction has taken place. Change in temperature. And children, so now I am sure today you have learned different observations which help us to determine if chemical reaction has taken place. So, you have learnt about change in state, change in color, evolution of gas and change in temperature. You have also learnt as a discoverer that learning by doing is very important. When you perform, you observe, you verify and inquire. So, put on your thinking cap and do some intelligent guessing. Note down the changes which are happening around you. I am sure every day you must be experiencing some chemical or some physical changes around you. Like water, remember, water is present in all the states, and whether change of water into liquid state and when it gets evaporated into steam, was that a physical or chemical change? And well, there is change in temperature also. So, learning by doing is a permanent learning. So, continue performing experiments, doing observations, and you will be the future scientist. Hello, my dear young students. As we observe changes around us, we see that there is large variety of chemical reactions taking place. We observed that change in state, change in color, evolution of gas and change in temperature. These may be indicators of chemical reactions. Now, we will learn symbolic representations of chemical reactions under the topic balancing of chemical equations. My dear young students, can you recall burning of magnesium ribbon from your previous classes? That when this magnesium ribbon is burnt in air, it gets converted to magnesium oxide. We also perform this chemical reaction. This magnesium strip has changed into this white ash. Now, as a student of science, how will you write this chemical reaction? Let us try writing it in a statement. So, what will the statement look like? When a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. So, here I have reframed the sentence and written like this: magnesium and oxygen combine to make magnesium oxide. Now, let us convert this into word equation. So, how do we do that? So, this is the word equation for reaction of magnesium with oxygen. Now, in this word equation, the substances that undergo change, that is magnesium and oxygen, are the reactants, and the new substance formed, that is magnesium oxide, during the reaction is the product. A word equation shows change of reactants to products through an arrow placed between them. The reactants are always written on the left hand side with a plus sign between the two reactants, and yes, similarly the products are written on the right hand side with a plus sign between them. Here only one product, that is magnesium oxide, was formed. So, I have written only one product over here. And always remember that the arrowhead points towards the products because this shows the direction of the reaction. Now, tell me, can you think of a still shorter way of representing this chemical equation? I am sure some of you have guessed it right. Chemical equations can be made more concise and useful if we use the language of chemistry, that is, chemical formulae instead of words. A chemical equation because it represents the chemical reaction. Now, students recall in class 9th chapter Atoms and Molecules. you learnt about formulae and valency. I am sure you remember. If not, you must revise them. Now, if we recall formulae of magnesium, oxygen and magnesium oxide, this word equation can be written as, for magnesium we can write Mg, oxygen represented by O2 and magnesium oxide represented by MgO. Now, students, along with me, count and compare the number of atoms of each element on the left hand side and on the right hand side of the arrow. Are the number of atoms of each element same? Let us count. Here we have 1 Mg and on the right hand side also 1 Mg. So, these are same, but here we have 2 atoms of oxygen and here we have only 1 atom of oxygen. So, these are not same. And what will such a equation be called? Because it is unbalanced. Mass also is not same on both the sides. So, such an equation is called skeletal chemical equation. This equation, because is not balanced, it is skeletal chemical equation. Now, can you recall law of conservation of mass you learnt in class 9th? What did it say? Yes, I am sure you must have guessed it right. Mass can neither be created nor destroyed in a chemical equation. That is, total mass of elements present in the product side. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Now, in this reaction, let us count the number of atoms of magnesium and oxygen on the left hand side and right hand side. Now, in this chemical equation, in left hand side, there is 1 atom of magnesium. So, I have represented it in the form of this circle here, Mg. Oxygen molecule, which is made up of 2 atoms of oxygen, is represented by 2 circles of oxygen, and here we have magnesium oxide. So, how do we represent this magnesium oxide? Well, this magnesium oxide can be represented by this. And children, do not carry a misconception. In class 9th, in Dalton's atomic theory, you have learnt that atoms are so tiny that they cannot be seen with naked eyes. So, here these are only visual representations to make you understand the concept. Okay. So, let us count and compare the number of atoms on left hand side and right hand side. Well, here we have 1 magnesium on the left hand side and 1 magnesium on the right hand side. But in this case of oxygen molecule, we can see 2 atoms of oxygen, and on the right hand side we have 1 atom of oxygen. How do we balance it? We change the number of molecules that we have and we find a combination that gives us same number of each type of atoms on both the side. So, it is going to be a little bit of puzzle, and we will play around with these kind of visual structures till we get same number of atoms on both the sides. So, are you ready? Okay. So, let me add another molecule of magnesium oxide. Now, young scientists, always remember, to balance the atoms, you cannot add another atom. You have to add a complete molecule like how I have shown here. So, let us again count the number of magnesium and oxygen. The oxygen atom are 2 over here, and on the right hand side 2 oxygen atoms. So, they are balanced now. Oh, but what have we done to the magnesium? Magnesium have become 2 on the right hand side and here only 1. So, let us balance this also. Here I am putting another atom of magnesium, and yes, now they are balanced. So, this is the visual representation of balancing. Now, we have balanced this equation in the visual format, but But how do we write it when you are doing it in your notebook? Well, my dear young friends, you will have to use coefficients. So, here we have 2 atoms of magnesium. So, we need to add 2 as coefficient in front of the magnesium atom, and oxygen molecule is 1. So, it is understood if you do not write anything, that means it is only representing 1 molecule. And here let us count the number of molecules of magnesium oxide, 1 and 2. Okay. So, here also we need to add coefficient 2 in front of MgO. So, now this becomes a completely balanced chemical equation of reaction between magnesium and oxygen. Now, my dear little scientists, let us take another very interesting example of formation of water. Yes. So, here we have a reaction in the statement form. Hydrogen gas and oxygen gas combine to make water. So, what do? First, we have to turn it into a word equation, and for word equation, we have to use a sign of plus between the 2 reactants, hydrogen gas and oxygen gas, and they are combining to form water. So, water is written after the arrow. Okay. So, this word equation can be written in a chemical equation form like this. Now, let us visualize what is happening behind this. So, here we have 2 hydrogen atoms forming a hydrogen molecule. So, I have represented it like this, and oxygen molecule is formed by 2 oxygen atoms. So, here we have the oxygen atoms, 2 oxygen atoms representing this oxygen molecule, which is forming water. So, water is represented like this over here. Now, again let us count and compare the number of atoms of hydrogen and oxygen on the left hand side and right hand side. Okay. So, here we go, hydrogens 1 and 2, and on right hand side 1 and 2. Are you counting with me? Okay. And oxygen on the left hand side 1 and 2, but on right hand side only 1, and we need to now balance this. So, what do? Never add a single oxygen atom, remember. So, we have to add a complete molecule of water. Okay, let us do it. So, here we go. Here we have added another molecule of water, but now what has happened? Okay, by doing so, we have balanced the oxygen atoms. See, you can count and see yourself. But what has happened to the hydrogen atoms? Now, on the right hand side, hydrogen atoms have become 1, 2, 3, 4, but on the left hand side, we have got only 2 atoms of hydrogen. So, what do? I am sure by now you know, and you are trying to tell me that why do not you add another molecule of hydrogen? Okay, so let me do that. And here I have added a molecule of hydrogen, and now every atom seems balanced. Okay. So, this is the visual balancing. How do we write it? Oh, you are so quick. Okay. So, 2 atoms of hydrogen. So, we need to add coefficient 2 in front of this like this. Oxygen molecule is 1. So, we need not write anything, and here see we have 2 molecules of water, 1 and 2. So, again we will write a coefficient 2 in front of water molecule. So, now this equation is balanced. Now, here I would like to point out a common mistake which students usually end up doing. You know what it is? Okay, let me tell you. What they do is, they feel that we have to balance the number of atoms of each element on left hand side and right hand side. So, okay, the trick they use is H2 and H2 is balanced. So, O2, why do not we make this O as O2? Well, children, never do that, because it was a water molecule. Now, by adding this subscript, what have you done? you have changed the entire structure and made a new substance. This is hydrogen peroxide. And while balancing of equations, you cannot form a new substance. So, always remember that you have to always add a coefficient. So, to balance it, we have to add 2. Never, children, add this subscript. If you add this subscript, the formula itself is going wrong. So, do you get it? Let me repeat that you always have to add the coefficient. You cannot add subscript or superscript. That will change the entire formula, and this equation was of formation of water. So, I am sure you will never do this mistake. Okay. So, now the balancing of water is complete. So, now let us move ahead and quickly do another reaction of formation of ammonia. Now, my dear little scientists, when you have to balance chemical equations, you cannot be always using visuals or drawings. The visuals were used only to help you understand the concept better. But to actually balance equation, see, I have another interesting equation in front of you. Here nitrogen gas and hydrogen gas, they are combining to form ammonia. So, let us quickly convert it first into the word equation by using plus sign between the two reactants and a sign of arrow showing that yes, ammonia has been formed. So, in this chemical equation, N2 plus H2 gives NH3. We are not going to use visuals. Actually, to balance equations, you have to use charts or table or little bit of maths, and these chart and table will help us to track the atoms on both the sides. So, let us count the number of atoms of each element on left hand side and right hand side. So, here we have 2 atoms of nitrogen and 2 atoms of hydrogen, and on the right hand side we have 1 atom of nitrogen. So, we write 1 and 3 atoms of hydrogen. So, we write 3. Well, but as you can clearly see that nitrogen on both the sides are not balanced, neither is hydrogen. So, to balance nitrogen, what can we do? Let us multiply this with 2. So, we get 2 atoms of nitrogen on the right hand side, and to balance the hydrogen, we will have to multiply the hydrogen this side by 2 and make it 6 atoms of hydrogen. So, here also let us make these hydrogen atoms 6. So, we have multiplied here by 3. Now, once you do the calculations like this, you can very easily add the coefficients. Here I have shown the coefficients to be added by red color, so that you can identify easily. So, okay, here we go. We write a coefficient 2 in front of NH3, and in front of nitrogen no coefficient to be written, and in front of hydrogen molecule you have to add coefficient 3. You have got a balanced chemical equation of reaction of nitrogen gas with hydrogen gas forming ammonia. Okay, so, we can move ahead now and take up another equation which we will need to balance. So, we are going to take an equation where iron reacts with water to form rust. Do you remember this equation? You have already done this in class 8th, but yes, we need to learn to balance it. So, here is the equation where iron is reacting with water to form iron oxide and hydrogen gas. Okay. So, what do we need to do? First, we need to count the number of atoms on both the sides. As we can see, Fe has only 1 atom, and this water, in this water we have 2 atoms of hydrogen. So, we write 2 over here, 1 atom of oxygen. So, we write 1 over here. And here on the right hand side, in iron oxide, we have 3 atoms of iron. So, I have written 3 here, and hydrogen we have 2 atoms. So, let us write 2, and oxygen we have 4 atoms. So, let us write 4. I am sure you are also tabulating and writing it along with me. Yes. So, now you can see that iron on both the sides are not balanced, hydrogen is balanced, but oxygen again is not balanced. So, what do we do? It is often convenient to start balancing with the compound that contains maximum number of atoms. It may be a product or a reactant, and in that compound select the element which has maximum number of atoms. Using this criteria, in this reaction iron oxide we can select, and which element do we select? Oxygen. So, here there are 4 atoms of oxygen and only 1 oxygen here in the left hand side. So, let us start by balancing oxygen atoms. Okay. So, here there is 1 atom of oxygen. So, what do? We will multiply it by 4 like this to balance it with 4 atoms present on the product side. So, now oxygen is balanced, but what have we done? If we have multiplied it by 4, that means we need to add 4 coefficient in front of water molecule like this, but while doing so the number of hydrogens have become now 8. So, here we go, this coefficient we have added here. So, hydrogens have become 8 on the left hand side. So, we need to balance the hydrogen on the right hand side also. Okay. So, let us multiply this also with 4 and add a coefficient 4 here in front of this hydrogen. So, here we write a coefficient 4. So, this is partially balanced equation. We still need to balance iron on both the sides, which is quite simple. Let us multiply iron with 3. Here we go. So, now you can see that all the atoms of each element on both the side are balanced. We only need to add coefficient 3 in front of iron. So, let us do that. Okay. So, I have written coefficient 3. Have you all noted, children? Okay, that is good. So, this has become our balanced chemical equation. Now, you have learnt how to balance a chemical equation, but students, can you tell me by looking at this equation that what is the physical state of iron, water, iron oxide or hydrogen? It is going to be a difficult task. So, there is one more step we need to learn, that is to mention physical states in brackets just after the elements which are written in the equation. So, here is the balanced chemical equation we have just done. Okay. So, writing of physical states in the form of symbol will make it more informative. How do we do that? Well, for solid state we will add in bracket a small letter S. For liquid state we will add a small letter L, and for gaseous we will add a small g, or we can also show it by a upward arrow. And well, what if the solution is made in water? We have to write within bracket in small letters AQ representing aqueous state. And yes, one more thing, if you get a precipitate, then you can show it by an arrow pointing downwards. So, that will make your equation very informative. So, let us try making this equation more informative by writing symbols of physical states. So, iron over here is a solid. So, what do? We can write S within brackets over here, and this is water. Until unless you mention the physical state, some of the children may wonder that water is in liquid form, but here this is in gaseous form, because iron will not react with cold water, it reacts with steam. I am sure you remember. And this is iron oxide, again it is in solid form. So, we can write S within the brackets, and here is hydrogen gas. Yes, so gas, you can either make an upward arrow or simply write within brackets a small g letter. So, this is now a completely balanced chemical equation of reaction of iron with steam to form iron oxide and hydrogen gas. Well, now sometimes we have reactions where certain other conditions are required. For example, the reaction condition of how much the temperature is, what is the pressure under which the reaction undergoes, or what is the catalyst used. So, various reaction conditions also can be used to make the reaction more informative. Now, if we have a reaction in which carbon monoxide, which is in gaseous form, reacts with hydrogen gas to form methanol, which is in liquid state. So, this reaction happens at a particular pressure, and that is 340 atmospheric pressure. So, such reaction conditions can be written above or below the arrow. Okay. So, now that you have learned how to completely write a balanced chemical equation, here is a task for you. You have seen green plants all around you, and you know that leaves are the kitchen of the plant. They make their food there with the help of sunlight, chlorophyll, carbon dioxide and water. Can you write this reaction? Try doing it. Here I have got it for you, because I need to tell you that where exactly you will place the reaction conditions. So, here we have the equation in front of you. 6 CO2 combines with 12 H2O to form glucose, that is C6H12O6, 6 oxygen molecules and 6 water molecules. And the reaction conditions? Yes, the sunlight and chlorophyll. This you can place above and below the arrow. Okay. Now, another interesting task for you. What you have to do is, I am going to show you an interesting reaction. Here I have made two solutions in water. In this we have lead nitrate solution, and in this we have potassium iodide solution. Observe carefully when I mix them what is the new substance formed, because you will walk with me on the path of discovery. Here we go. Wow, bingo, what a bright cadmium yellow. Now, you have to be a discoverer, explore and find out that the reactants, that is the lead nitrate and potassium iodide, if these two reactants have interacted with each other, what could be the substance formed? Write it in a form of a sentence and then convert it into word equation. And I am sure you will very easily be able to balance the chemical equation. All you have to do is count and compare the number of atoms of each element on both the sides, and by adding coefficient, you can balance the number of molecules. So, what we have learnt? Yes, how to balance a chemical equation and make it more informative by adding physical states in brackets after you write the formula of the element or compound which is coming in the chemical equation. And yes, always remember that you have to also mention the reaction conditions above and below the arrow. So, that will make your chemical equation completely balanced. I am sure you all young discoverers must be very excited after seeing this reaction. The more you practice, the more you will become perfect at balancing chemical equation perfectly. So, happy learning, dear discoverers. Hello young friends. We are discussing types of chemical reactions. So far, we have discussed combination reactions. Let's explore further. As you can see, in a boiling tube, I have taken 2 grams of ferrous sulfate crystals. I want you to note the color of the ferrous sulfate crystal. Aren't they light green in color? Now let's heat the boiling tube over the flame of a spirit lamp I have here. Well, first let me light the spirit lamp. Whenever you are doing such experiments, make sure you are doing under the observation of teacher. So here is the boiling tube with ferrous sulfate crystals. Let me hold it with the test tube holder and now place it over the flame. Now friends, recharge your observational skills, and while we are heating, observe the change in color of crystals carefully. And always remember, the correct way of heating the boiling tube is to tilt it at an angle of 45 degrees. And also, never point the mouth of the boiling tube at your neighbors or your own self. Can you see the color change happening in the color of the ferrous sulfate crystals? And yes, the fumes coming out of this may be very poisonous, so you have to be very careful. Never inhale it directly. Can you note the change in the color of the ferrous sulfate crystals? I think the green color has changed. And yes, the crystals are now turning brown. We can also smell characteristic odor, and the correct way is wafting gas gently towards the nose. Never inhale the gas directly. It may be harmful to you. And can you hear the crackling sound? Aha! The reactant ferrous sulfate is breaking down. Now friends, can you see these water droplets on the inner surface of boiling tube? From where have these water droplets come? Well, the ferrous sulfate crystals, that is FeSO4.7H2O, lose water when heated, and color of the crystals change. This process can be represented by the chemical equation you can see on the screen. Ferrous sulfate is shown decomposing into ferric oxide, sulfur dioxide, and sulfur trioxide. Ferric oxide, as you can see, is solid, while SO2 and SO3 are gases. Now friends, put on your thinking caps and tell me what will happen if I keep this moist litmus paper, the blue litmus paper, on the mouth of the boiling tube from where the gases are being emitted. You've already studied in your earlier classes about the change of the color of the litmus paper. So I'm sure you can tell me whether you will see any change in this blue litmus paper. And what would have happened if I would have kept a red litmus moist paper? Think. If not, explore and find out. In this reaction, we observed that a single reactant breaks down to give simpler products. Such a reaction is called decomposition reaction. Okay, now let's talk about one more example of decomposition reaction. You all are very familiar with chalk piece. In language of science, we call this calcium carbonate. Do you know, on heating, calcium carbonate breaks down to form calcium oxide and carbon dioxide? And I'm sure if I ask you, how will you know that this gas is carbon dioxide only? You will quickly tell me that carbon dioxide turns lime water milky. We know that calcium oxide is also called lime or quicklime. And what is the common name of calcium carbonate? Yes, you have guessed it right. It's limestone. And remember, decomposition of limestone is an important decomposition reaction. It is used in various industries. One I am going to tell you, and that is in manufacture of cement. You may explore a little and find out its other uses. As I told you, you are discoverers. You may explore through internet or may visit libraries nearby or your school library. I'm sure it is full of books. And always remember to share your books with your peers. Now, these two reactions which we have done, we observe that for breaking down the reactants, energy was used. Which form of energy was used? Yes, you saw it. It was heat energy. Now, can we now define it? When a decomposition reaction is carried out by heating, it is called thermal decomposition. To understand this better, let's do another activity. Here, I have lead nitrate powder in a boiling tube. As students of science, always remember to use chemicals judiciously, as they ultimately go into the drain and harm the environment. So here, I have just taken 2 grams of lead nitrate. Let me heat it over the flame. And here I am reminding you, never do this experiment on your own. You should always do it under the assistance and guidance of a teacher. I am holding this tightly with the test tube holder and I will be heating it. Again, keeping this, remember, at the angle of 45 degree. And yes, note the color of the lead nitrate, because slowly there is going to be a change. This is what the magical world of science is about. Again, I can hear crackling sound. That means the reactant has started breaking down. And yes, children, always remember that the mouth of the tube should never be pointed at your neighbors or your own self. You have to be very careful. Emission of brown fumes can be seen. Look here and be careful. Never inhale them directly. They can be harmful to you. I hope you are noting your observations. These fumes are of nitrogen dioxide. Lead nitrate has decomposed into lead oxide, nitrogen dioxide and oxygen. So as you can see on the screen, lead nitrate, that is 2 PbNO3 whole twice, on heating gives 2 PbO, that is lead oxide, and 4 NO2, that is nitrogen dioxide plus O2, oxygen. And always remember to write balanced chemical equation, and you must also mention physical states in small letter within the brackets. Let's explore further and develop deeper understanding. Let's watch this video. What's happening in this video? For this experiment, the materials required are a stand, we need a bell jar, boiling tubes, rubber cork fitted with 2 electrodes, crocodile clips with wires, and a 9-volt battery. Here, bell jar has been shown with rubber cork fitted with 2 electrodes. First, we have to fill water in bell jar. When we put water in bell jar, care should be taken that electrodes are immersed in it properly. 2 small tubes are taken filled with water to the brim, and we are now inverting them over the 2 carbon electrodes. When you are doing this, care has to be taken that no bubble is formed. Otherwise, we will not get to know about the exact ratio of the gases. Now both the test tubes have been placed over the electrodes. And now crocodile clip is attached to 9-volt battery. Remember, this is decomposition using electricity. So water will decompose by passing electricity. Few drops of dilute sulfuric acid is being added to the water so that reactions become fast. Now look at the video carefully. See, the reaction will become fast here. Slowly, the gases will collect in these. What do you see? Formation of bubbles taking place at both the electrodes. Is the volume of gas collected the same in both the test tubes? In one, you see more gas, but in other there is little gas, because the ratio is different of the gases, that is 2:1. See here, you can see effervescence. Do you know why? Now we will test. How will you verify that the gases produced are oxygen gas and hydrogen gas? We will test these gases one by one. We will remove the test tubes carefully and safely. If we will remove the finger from the mouth of the test tube, gas will escape. Where we get a pop sound by placing burning splinter, it means gas is hydrogen. Oxygen helps in burning. You all know this from your experience. So look here, bringing burning splinter near mouth of other test tube, it is supporting burning. See, the flame is becoming brighter. Have a look at balanced chemical equation of decomposition of water. Here, what do you see on screen? 2H2O gives 2H2 plus O2. Remember, you have learned that balanced equation helps you to do calculations. Look at this balanced equation. The products obtained are 2H2 and 1O2. So you see, hydrogen and oxygen is present in the ratio of 2:1. Now, one thing you need to tell me, which form of energy was used for breaking down the reactant in this decomposition reaction? Yes, as you saw, this is decomposition by electricity. Now, moving on further, here's another interesting observation from your daily life. In market, we get photochromatic glasses. In bright sunlight, their color becomes dark. And when we shift in the room, they again become transparent. Have you ever wondered what is the science behind it? Let's learn it through this video. In this video, you can see we have taken 2 gram silver chloride in watch glass. What was its color? Yes, it was whitish. And it is placed in sunlight for some time. After some time, what changes do you observe in the color of the silver chloride? Silver chloride turns gray in sunlight to form silver metal. This is what happens in photochromatic glasses. In glass, silver chloride and silver bromide are present. When light falls on colorless glass, AgCl and AgBr break into ions, chloride ions and bromide ions, and show its gray and brown color. If their mixture is taken, then we get a mixed shade. As more sunlight falls, more decomposition happens and glass becomes dark. Now, moving away from sun, these ions combine by combination reaction, remember? They give back AgCl and AgBr, which are transparent. Now, we can easily write chemical equation for this chemical reaction. Let's have a look at the chemical equation. It says 2AgCl in presence of sunlight gives 2Ag and Cl2. Silver bromide also behaves in the same way. 2AgBr in presence of sunlight gives 2Ag plus Br2. The above reactions, they are also used in black and white photography. And what form of energy is causing these decomposition reactions? Yes, these are decomposition by light. Let's have a quick recap of what we have learned so far. These 3 were reactions in which they require energy or they absorb energy for breaking down the reactants. So they were endothermic reactions. Thermal decomposition, which we had done of ferrous sulfate. The second was decomposition of calcium carbonate. And the third one was decomposition of lead nitrate. And we also did decomposition by electricity. And now you just now saw decomposition by sunlight. Now observe carefully. I will show you an activity and you will tell me whether it is an exothermic or an endothermic reaction. Here I have taken around 2 gram barium hydroxide in this boiling tube. Now I am going to add ammonium chloride. Approximately, these both have to be taken in 2:1 ratio. So here I am adding approximately 1 gram of ammonium chloride. And after adding it, now I am going to mix it with the glass rod like this. And children, always remember to use chemicals judiciously because they harm the environment. And this can very easily be felt by visually impaired students. They can feel change in temperature. I can feel it has become cold. You can also check and verify by using thermometer that whether the temperature has decreased or increased. Now tell me, here is a small task for you, whether this is exothermic or endothermic reaction. And yes, I can also smell some gas. What gas could it be? Why don't you write the chemical equation? And here is a small task for you. In your kitchen, mix lemon juice and baking soda. Feel it. Does it feel cold? I'm sure you will enjoy being a little discoverer by finding the answers yourself. So you go into the kitchen till I join you with the next interesting reaction. So far, we have done various chemical reactions and you have learned to record your observations, take down the word equations and make chemical balanced equations out of them. And children, always remember to use chemicals judiciously because they harm the environment. And most important thing, that always keep your surroundings clean. We have so far learnt about combination and decomposition reaction. Now let's learn about another type of reaction. You must have played Kho game. What happens in that? The chaser pats the back of another player of her team and says Kho and takes her place. And then that player chases other team member. Sometimes some metals also take place of other metals. Let's see this through a reaction. Here I have two iron nails. One I will keep for comparison and the other one I have tied with a thread. And this I am going to place in copper sulfate solution which I already have prepared like this. And this is also copper sulfate solution which I have kept aside for comparison. Now let's see what happens after 20 minutes. Well, look at the color change of the solution and compare it. The copper sulfate solution which was blue due to presence of copper ions. Now the color has faded. And where has the copper gone? Now I'm going to take out the iron nail. Are you ready to note down your observations? Okay, so here we go. And look, this is the iron nail which we have now. And in this iron nail, let's compare it with the iron nail which we had kept for comparison. See the difference? And now, if I rub the surface of this nail, what do you see? All the copper from the copper sulfate solution has come and stuck to the surface of the iron nail. So, can you tell me which metal from copper sulfate solution has displaced the other metal? I'm sure you can guess. And one thing more, children, you can always have alternative resources to do this reaction. Don't worry if you don't have boiling tube. Instead of boiling tube, you can even use a glass bottle or you can use a plastic bottle cut into half. But never stop learning and learning by doing specially. Now, after we have compared the intensity of the blue color of copper sulfate solution in test tube, you must be wondering how to write it down in the form of chemical reaction. Chemical reaction can be written as shown in the screen. Fe was the iron metal which was dipped in copper sulfate solution. So we have written Fe in brackets S plus copper sulfate. Within brackets we have written aqueous because the solution of copper sulfate was made in water. And what does it give us? Ferrous sulfate, aqueous solution plus Cu, that is the metal. So in this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. And my dear discoverers, can you tell me what would happen if we would have kept the iron nail in copper sulfate solution for longer hour? Well, do it, try and conclude. Now I have another interesting task for you. Put on your thinking caps and tell me, what would happen if instead of this copper sulfate solution, you take copper chloride solution and add lead metal in it? Will lead metal displace copper from copper chloride solution? Well, I'm sure you will be able to give the answer. Explore a little, perform it yourself, because learning by doing is what is necessary, because this is the way you will become lifelong learners. We just saw how a metal displaces metal ion from its aqueous solution. What if reaction takes place between two aqueous solutions? I'm sure you all are curious to know. Okay, we are little scientists and we believe in learning by doing. So let's perform an activity. Here I have taken two solutions. One is of barium chloride, the other is sodium sulfate. And note the color. See, they both look transparent. And now what will happen when I mix the two solutions? Observe carefully. And now let's mix the two solutions. What do you observe? Wow, what a magical world of science this is. This insoluble white substance is called a precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. Formation of barium sulfate and sodium chloride has taken place here. You can see it on the screen. The chemical reaction has been depicted in the form of chemical equation. Now, what causes formation of white PPT? The white precipitate of barium sulfate is formed by the reaction of sulfate ions and barium ions. The other product formed is sodium chloride, which remains in the solution. Such reactions in which there is exchange of ions between the reactants are called double displacement reactions. Now it's time for a task. Recall the activity where we mix solutions of lead nitrate and potassium iodide. What was the color of the precipitate formed? Can you name the compound precipitated? And also write the balanced chemical equation for that reaction. Was that a double displacement reaction? All what you have done here, you may also refer to the QR codes given in your textbook or various links of various videos. And also remember, if you perform certain activities in group with your team, with your peers, you will enjoy it more. Here I have a very interesting group activity. Put approximately 25 ml of water in 3 beakers, which you have named, say, A, B and C, and copper sulfate solution in the 4th beaker. You may measure and record the temperature of each liquid contained in the beakers. And now add approximately 2 spatulas of potassium sulfate, ammonium nitrate, anhydrous copper sulfate, and fine iron fillings to beakers A, B, C or D, or which you have named on the basis of your friends and stir them. Finally, measure and record the temperature of each of the mixtures which you have prepared in the beakers. Find out which reactions are exothermic and which are endothermic in nature. You must have observed that iron articles are shiny when new, but get coated with a reddish brown powder when left for some time. This process, I'm sure you know, that commonly is known as rusting of iron. And I'm sure you can recall the reaction of rusting of iron you learnt in your previous classes. What was it? It was reaction of iron with oxygen present in the air along with moisture. You may also draw a scene like this, where you may depict some articles or substances drawn where oxidation is taking place. I'm sure you will enjoy drawing with color, or you may even shade it with pencil. Some other metals also get tarnished in this manner. Can you recall? Have you noticed the color of the coating formed on copper and silver if they are left in air for some time? Yes, you will enjoy exploring and finding out the answers to these questions. Can you suggest ways for protection of metal surfaces from reaction with moisture? Explore ways. You may go to your library or search through internet. Be a discoverer, like I told you before also. And yes, be observant as you learn from your surroundings. Okay, now I have a little task. Do some intelligent guessing. Can you tell me what will happen if you heat copper powder in china dish? Well, I'm sure you must have guessed it right. Oxygen from air starts reacting with copper. And what will you observe? The surface of copper powder will turn black. This is because oxygen gets added to copper and copper oxide is formed. And you can very easily represent this chemical reaction. See on your screen, copper and oxygen on heating are giving copper oxide. Now, if hydrogen gas is passed over this heated material, that is copper oxide, what will happen to the black coating? Does the surface turn brown? Well, yes, the reverse reaction takes place and copper is obtained back. You can see it on the screen. So, if a substance gains oxygen during a reaction, it is said to be oxidized. And if a substance loses oxygen during a reaction, it is said to be reduced. Now, what happened during this reaction? Copper oxide is losing oxygen and is being reduced. And hydrogen is gaining oxygen and is being oxidized. So, in other words, if we try to explain, one reactant gets oxidized while the other gets reduced during a reaction. And such reactions are called oxidation reduction reactions, or in short, redox reactions. There are many examples, and redox reactions are happening all around us. On the screen you can see zinc oxide is reacting with carbon and is giving zinc and carbon monoxide. Now, what is happening in this reaction? In this, carbon is oxidized to carbon monoxide and zinc oxide is reduced to zinc. And look at another reaction where we have manganese oxide reacting with acid. Which acid is it on the screen? Yes, it's hydrochloric acid. So when manganese oxide reacts with hydrochloric acid, we are getting three products. We are getting manganese chloride, water, and chlorine gas. Now, can you find out whether in this reaction which substance has got oxidized and which has got reduced? Now, that is a little task for you. So, you may note down the reactions nicely in your notebook and observe where oxygen is getting added and where oxygen is being taken away. Now, from these examples, you can easily say that if a substance gains oxygen or loses hydrogen during a reaction, that becomes oxidized. And if a substance loses oxygen or gains hydrogen, then it is reduced. I'm sure now you look around your surrounding and find out what are the effects of oxidation reactions in everyday life. And so many metals around you in the country, you may be seeing getting corroded. Think of ways how you can protect them. I'm sure you will find out, and you've already learnt also. So just collate your data, and I'm sure now you will stop wondering why your iron gate keeps getting painted after season. Now children, here I have a packet of chips which I bought around 10 days ago. Sometimes you must have felt that the smell when you open it after a long time, if it has been kept, the smell changes. Have you ever tasted or smelled the fat or oil containing food materials which have been left for a long time? Yes, when fats and oils are oxidized, they become rancid. Rancid means their smell and taste change. Usually, substances which prevent oxidation, they are called antioxidants. So, they are added to foods containing fats and oil. And that is why we keep food in airtight containers, which helps to slow down oxidation. Do you know that the chips packet you buy, which gas is it filled up of? And why do the manufacturers flush bags of chips with gas? And which gas could it be? So, nitrogen helps prevent the chips from getting rancid. Well, children, so it's time to recall and revise what we have learnt in the chapter Chemical Reactions and Equations. We have learnt various reactions. You have performed so many reactions, and that is what learning by doing is. Some you learnt with experimentation, some you learnt with observation, and some videos also you watched. And I'm sure you noted down all the observations and you collected data. You inferred from your data that which kind of reaction was taking place. So, you learned to differentiate between different types of reaction. You also learned to define what kinds of reactions were taking place. And you learned about the endothermic and exothermic processes along with it. So what were the reactions we've learnt? If we quickly do a recap, we did combination reactions, we did decomposition reactions, we did displacement reaction and double displacement reaction, and also oxidation and reduction reactions. And well, you were also motivated to do certain group activities because with your peers you enjoy more. And yes, bonding becomes strong. And once the bonding between the peers is strong, the learning becomes stronger. Whenever you are doing learning, either by doing it yourself or by watching experiment or by exploring through internet, remember that you have to take care of environment. Never do any activity which will harm the environment. You must always remember to keep your surroundings also clean. Happy learning.